Hello everyone, welcome to Computer Organization and Architecture class. In this unit, we will talk about base conversion and show you how to convert a number in any base to base 10. Base conversion talks about how to convert numbers between different bases. To avoid confusion and for simplicity, we will use the shorthand as shown on the screen to represent a number as shown in blue, in a specific base as shown in red, in a pair of parentheses. For examples, number 198 in decimal system, that is base 10, is represented as 198 with a subscript 10. Number 110 in binary system, that is base 2, is represented as 110 with subscript 2. Number AB in hexadecimal system, that is base 16, is represented as AB with subscript 16. To simplify how to convert between different bases, as humans mainly use decimal system, that is base 10, we will show you how to convert a number in any base to base 10 and how to convert a number in base 10 to other base. In this way, you can use base 10 as a mediator to perform conversion between any bases. Before we explain how to convert a number in any basis to base 10, we will need to introduce two terms. That is, most significant digit and least significant digit. The most significant digit is the leftmost digit in a number, which has the greatest impact on the value. Contrarily, the least significant digit is the rightmost digit in a number, which has the least impact on the value. For example, assume we have a number 804. 8 is the most significant digit because this digit represents 100. If we change 8 to 6, the value is reduced by 200, not 2. 4 is the least significant digit because this digit represents 1. If we change 4 to 2, the value is reduced by 2. To convert a number from any base to base 10, we need to apply polynomial method. The polynomial method is defined in the equation as shown on the screen. In the equation, m and n are numbers of digits to the right and left of the radix point, respectively. Bi is the value of digit in position I, and k is the base. We will demonstrate the polynomial method using the example on the screen. In the equation, the symbol m is the number of digits on the right of the decimal point. In this example, we have 2 digits on the right of the decimal point. That is 0, 1, and thus m is 2. The symbol n is the number of digits on the left of the decimal point. In this example, we have 4 digits on the left of the decimal point. That is 1010, and thus n is 4. As shown in the shorthand, the number 1010.01 is in base 2, and thus k is 2. The symbol B subscript I represents the digit in position I in the number. The sigma symbol indicates the sum of the BI multiply k to the power of I for each I, where I is from -2 to 3. For instance, the most significant digit is 1, which represents B3 at position 3. Therefore, B subscript I multiply k to the power of I is 1 multiply 2 to the power of 3, which is the first term in the calculation below. The second digit from the left represents B2 at position 2. Therefore, B subscript I multiply k to the power of I is 0 multiply 2 to the power of 2, which is the second term in the calculation below. Similarly, we can obtain the value for each term and then take the sum of all terms as a decimal value. Please notice that any number to the power of 0 is 1, not 0. It looks complicated, right? Don't worry. The instructor will show you an easy way to solve the same question. Assume we want to convert a number ABC.DE in base M to base 10. Step 1. Write down each digit as shown on the screen. Step 2. Write down multiply base after each digit. Step 3. Identify the digit on the left of the decimal point and index this digit as 0. We increase the index by 1 to the left and decrease the index by 1 to the right as shown in green. Step 4. Write down the index to the corresponding digit as the exponent. Step 5. Calculate each term and write down a plus symbol between two adjacent terms to add them up. You can use these 5 steps aforementioned to convert a number in any base to base 10. Any questions?